So we've learned three different methods to solving a quadratic. We've learned how to solve quadratics using square roots when there's no bx term. We've learned how to use factoring when the quadratic is factorable. And we've learned how to use completing the square when there is a bx term and it's not factorable. Today, we are going to learn the way that works for every single quadratic equation, and it is the one that I use the most. So it is kind of the granddaddy of them all. So that's where we're heading. But before we get there, let's just take a minute. These would be our SMART problems. So I'm asking you to pause the video with a piece of paper and choose the best method for each of these quadratics and solve them, please. And when you are set, unpause the video and we will see how you did. Okay, let's take a look at number one. I noticed there's a bx term, so no square roots for you. The next thing I notice is I just quickly look, it's in factorable form, and I just look at the 42. There's no number other than 1 as the a, so this could be a quick factoring. I think of 7 times 6, 1 has to be negative, and the difference between 7, this looks factorable to me, so I'm going to try factoring. But I kind of do a quick scan before I commit. So I'm believing that 7 times 6, and in order to get the positive, the 7 is going to have to be the positive, and the 6 is going to have to be the negative, right? And then if this has to equal 0 using the zero product property, so this would have to be -7, and this would be have to be +6, and look how quickly I solved that quadratic. Number 2 has no by term, just a different variable here. So how about square root? I'm going to divide both sides by 4, and I just happen to notice that 25 and 4 are perfect squares, so I just, kind of left those the way they are. So there's the 25 over 4, and I take the square root of both sides. Square root of 25 is 5, the square root of 4 is 4. Don't forget your plus or minus, because there are 2 roots, 2 answers, 2 x-intercepts. And if you put 2.5 here, that would absolutely be fine. This one has a bx term, so no square roots. And I very quickly thinking 3 and 1, there's no way this is factorable, so I have to use completing the square. Let's talk about completing the square again. The first thing is we have to have an a of 1, and we do. The second thing is that 3 is going to have to rotate around to the other side, so we are going to subtract 3 from both sides. I'm going to take 5 divided by 2, which is 2.5, and that 2.5 squared is what I'm going to add to both sides. I'm going to leave it written as 2.5 squared because that makes the next step easier over here, but 2.5 squared is 6.25, so it makes it easier on that side to simplify it. So here, I'm going to take the x, I'm going to take the x from the front and the 2.5 and make that the perfect twins squared. And over here, this becomes 3.25. And now, because the whole side is squared, I can take the square root. Don't forget to put your plus or minus. And when I take the square root of that 3.25, I'm going to subtract 2.5. So I'm going to take the positive root minus 2.5 and the negative root minus 2.5. And you should get about -0.70 or -4.3. So the square root of 3.25 minus 2.5 and the negative square root of 3.25 minus 2.5. And there are the 3 methods that we have used so far. So today we're going to learn the quadratic formula. It is the method that I use the most. Square roots I'll use quickly if there's no bx term, but usually I head, to be honest, right for the quadratic formula. Now where I'm going to start is showing you how we get that formula to be. I'm going to give you the reason why. So first of all, the quadratic formula will solve any quadratic equation. Whether you could have used square roots, whether you could have used factoring, it will solve it. And here is your standard form of a quadratic equation, and the quadratic formula is the green guy right here. So you find your x equals, it's going to be the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. The a can't be 0, otherwise it wouldn't be a quadratic. And the b squared minus 4ac has to be greater than or equal to 0, otherwise you'll have a negative under the square root, and we will talk about what that is, but that's a problem. So the next slide is my explaining why this formula exists. And what I am going to do is take ax squared plus bx plus c, and I'm going to complete the square, but I'm leaving the a, the b, and the c in there, and I'm going to solve it by completing the square, and this will be our result. So if the next slide boggles your mind, if you can simply use the formula, good for you, and that's what we're going to do after that slide. But for those of you that are sitting there going, where the heck did this thing come from? I want to explain it. So we're going to prove this formula. So I'm going to start with ax squared plus bx plus c equals 0, the standard form of a quadratic. I'm going to subtract the c from the other side to get it ready to complete the square. I don't know what a is, so I'm going to divide everybody by a to make sure that there's a 1 in front. So I divide this guy by a, and I divide that guy by a. The next thing I'm going to do is take ba and divide it by 2, which would give me b over 2a. There it is. And I'm going to add it to the left, and I'm going to add it to the right. So b squared 2a squared gives me the 4a squared here. I need a common denominator, so this guy over here needs to be 4a squared, so I'm going to multiply top and bottom by 4a to get the bottom to be 4a squared. B squared minus 4ac, you're going to see that on the top, all over 4a squared. I'm going to undo squaring by taking the square root. Don't forget, that will give you a plus or minus. B squared minus 4ac. And the square root of 4 is 2, and the square root of a squared is 2a. And then I'm going to subtract this, which would give me a negative b. And since they have a common denominator, I can just take the negative b in the numerator plus or minus what was there all over 2a. Oh, by the way, there's the quadratic formula. So basically what I did was I took the standard form of a quadratic equation, and I used completing the square on the formula. I transformed the formula. We had done several formulas that way back when. I transformed the formula to get this. So now I can just use this, and I don't have to use completing the square anymore. Okay, so let's move on and use it. Okay, so here is the quadratic formula, and here is the quadratic equation that I want to use. So the first thing is you need to have it equaling 0. So you need everything over on the left, like factoring. Then you're going to look at your coefficient of the x squared. That'll be your a. You're going to look at your coefficient of the x term, and that'll be your b. And the constant, again, making sure that all of these are on the same side, is the c. And now it is simply a substitution. I'm going to take the opposite of b, so the opposite of negative 3, plus or minus the square root of b squared minus 4. That 4 is part of the formula. The a is 1, and the c is negative 4, and it's all over 2 times a. Once you've done that, it's basically a calculator exercise. Now I'm going to warn you, where do people make mistakes? Underneath the square root. This is where people will goof up, even putting it into a calculator. Right now I'm going to talk it through not using the calculator, but just be careful. You got to have this negative 3 in the gloves when you put it in the calculator. So first of all, the opposite of negative 3 is going to give me a positive 3. The negative 3 squared would give me a positive 9. And you're going to notice there's 3 things being multiplied here, and 2 of them are negative. So this would be negative 4 times 1 is negative 4, and negative 4 times negative 4 is a positive 16. And the bottom is just 2. So do you understand kind of where this came from? Do you see the 9? And do you see the plus 16? The number one mistake is to put a negative in front of the 9, and also like to have the sign wrong here. So you just have to be careful. Now 9 plus 16 is 25. And the square root of 25 is a perfect square, so that becomes 5. And basically, there are two answers hiding here. There's the positive road and the negative road. 3 plus 5 is 8. Divide by the 2. 3 minus 5 is negative 2 divided by the 2. And this parabola, which is going to be opening up because it has a positive a, is going to intersect the x-axis at positive 4 and negative 1. When I look at these answers, because they're integers, this guy actually could have been factored. But I'm going to start with some nice ones, basically, so that you can just get comfortable using the formula. Okay, so we're going to do it again. So we get over to our quadratic. We make sure that it's ax squared plus bx plus c equaling 0. So make sure the a, b, and c, they're all on the same side. Then you're going to find what your a is, what your b is, and what your c is. Now, you don't have to write that down if you were in class. I'd say if it helps you, fine. If not, but, just make sure you know who's who. And now we're going to substitute. So, be careful. Make sure you put the right number in for the right variable. So we need the opposite of b, which would be, negative 2, plus or minus b squared, which would be 2 squared, minus 4, times a, which would be 7, times c, which would be negative 1, all over 2 times 7. Now, if we were in class, I would be asking you to show me this substitution. Like, don't just go to the calculator. So show me what you put in for everything. And I'm always okay if you just multiply the 2 times the a. You don't have to write 2 times 7. You also can just do the negative b up here. But show me what is underneath the square root, because like I said, this is where people make mistakes. So always show your substitution. And now it's really important to make sure you get this b squared minus 4ac right. So we already have the b squared, but a negative times a negative. So there are 3 things being multiplied, 3 factors. When 2 of them are negative, you're going to get a positive. And obviously, if they were all positive, you would get a positive. If you only have one of them being a minus, then it will stay a minus. But because this negative 4 times this negative 1 is going to give you a positive 4 times 7, that should be a 28, not a minus 28. And then you're going to add those two. And we're kind of looking at this. Now, when we go, so this is kind of important. I would ask you to do this substitution step. And then I really need to see this step I'm circling here to see what this b squared minus 4ac is. So you really don't need this middle step to show me, but you want to show the substitution, and you definitely want to show this before you kind of do your final step here. Now notice that the square root of 32 is not a perfect square. So when you take, now you could literally pick up your calculator right now and put negative 2 plus the square root of 32, and you must hit enter and then divide it by 14. If you don't hit enter, the order of operations are going to be wrong. So right now, pick up your calculator and take negative 2 plus the square root of 32 and make sure you hit enter and then divide it by 14, and you will see the 0.26. If you take negative 2, go back, minus the square root of 32, press enter, divide it by 14, you'll see the other root. And in this case, this was not factorable because there was not a perfect square under here. This one, you could not use factoring. You would have had to use completing the square. But by using the quadratic formula, you're doing the completing square. You just already did that to get the formula. We're going to round to the hundredths, so we usually leave 2 places. So what I would encourage you to do right now, see if you can pause the video and try this one yourself. Get your final answers, come back, and we'll see how you did. Okay, so let's check in. A is 3, B is negative 19, and C is 40. I'm going to substitute in. And there's my substitution step. Here is kind of the part we have to be careful. See, there's only one minus this time. And when I take 361 minus 480, did you see the problem that happened here? We got a negative under the square root. What's going on here? That's not going to work out. We're not going to get two answers there. When you end up with a square root of a negative, that means that this parabola, which is opening up, is not going to hit the x-axis. So there are no solutions. There are no x-intercepts, and there are no roots. So there's one of the special cases. So remember that we can either get two answers, no answer, or one answer. Now, to get the one answer where the parabola is vertexed on the x-axis, only 1 point, this right here would have to be 0. So there's 3 possibilities that can happen. Before we move on, why don't we take a minute to just kind of see where do we use this stuff, and then I'm going to give you a way to remember the formula. And you're going to have to sing with me, so get ready. Okay, so vertical motion we've talked about in the past. There are basically 2 models here. One is imagine that you had your keys to your mother's car, for instance, and you were upstairs and she had left her keys in her bedroom, and she calls up to you and says, can you drop the keys down? So you put your hand out the window with the keys and you drop them down. You simply open your hand and drop them. Then you would be using this first equation. Now, if you were angry with your mother, and instead of simply dropping them, you put some force behind there and threw them and sent them down with some force, you would be using the second model because there would be velocity. This is the same equation that we're going to use. This one is missing the VT because there's no initial velocity. You're not putting any force behind it. So if you kind of just remember the second formula and understand that when you drop something, the V would be 0, these are really kind of the same thing. So we've talked a little bit about this before. We did a firework in the past. And I told you we would start to develop these equations ourselves. So this is the basic formula, and I'll explain this -16 down here in a second. So this h is the height in feet at a given time. The s out here is the initial height. So when you put your hand out the window, you were so many feet off the ground. That would be the start height. The h would kind of be like the end height. T is your time, seconds that the object is in motion, and V is that initial velocity, which would be feet per second or meters per second, something like that. So in this model, you're going to notice that the coefficient of t squared is this -16. That is actually 1/2 the acceleration due to gravity. On the surface of the Earth, the acceleration is approximately 32 feet per second per second. So in a vertical motion model, you'll always see this -16 in front of the t squared. That's basically gravity working on the object. So let's take a look at an example. Here's the case of the keys being dropped from the window. So say that window is 36 feet above the ground of your friend or your mom, and your friend doesn't catch them. How long will it take for the keys to reach the ground? So notice I'm using that first model because I'm not throwing them at my friend, I'm just dropping them. So the only force there is going to be the gravitational acceleration there. So now we just have to kind of fill in the right pieces. So this 36, where does it go? It's your start height. So that 36 is going to take the place of the S. Now, if your friend clumsily drops them, the end height will be a 0 because they hit the ground. And now you just have to solve this quadratic and you'll have the answer as to how long, what time, did this happen. So we're going to subtract, hey, no BT term, I'm not using the quadratic formula. I'm going to use square roots. I'm going to subtract the 36 from both sides. I'm going to divide by -16. 36 divided by -36 divided by -16 is 6/4, which is 1.5. Excuse me, 6 divided by 4, take the square root, is 1.5. and there's a plus or a minus. Now, it doesn't make sense that the time would be negative, so you're going to take that positive root there, 1.5 seconds. Now, what is the negative 1.5? Well, remember that when you started, you were off the ground. So this is a parabola opening down. It is going to mathematically hit the x-axis in two places, but that negative 1.5 seconds is sort of like the time it took to get it up to the 36 feet on that arm of the parabola. You know, you're already starting sort of 1.5 seconds up on the parabola, if that makes any sense. So that's what the negative 1.5. If you went back in time, negative 1.5 seconds, you would bring those keys, you know, sort of starting at a 0, but you know, before you went up to the 36 feet. Okay, let's take a look at another application of this quadratic formula, and this time we'll get to use the quadratic formula. So members of the science club launch a model rocket from the ground level with starting velocity of 96 feet per second. After how many seconds will the rocket have an altitude of 128 feet? They are starting on the ground this time, so think about what S is. They have an initial velocity, think what 96 is, and they want to know when is it 128 feet. So let me just get these numbers over here. Here is our vertical motion model. The H is going to be 128. That's kind of sort of our end height. We started at 0, so S is going to be 0, and the V is going to be 96, and we substitute in. We're going to use our quadratic formula this time because we have a BT term, but in order to do that, I've got to wrap that 128 around so that all of the terms are on one side equaling 0. Okay, now quadratic formula. A is going to be the negative 16, B is going to be the 96, and C is going to be the negative 128. I'm just going to uncover this box. Okay, and this is the substitution. The opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And it now becomes a calculator exercise. So the opposite of the 96 and the 2A, pretty easy. 96 squared is 9,216, and a negative times a negative is a positive times a negative will be a minus again. And this time, notice it's not going to be negative. We are going to get a number underneath that square root, which will be 1,024. So I pick up my calculator, negative 96 plus the square root of 1,024, hit enter, and then divide by negative 32. And then take negative 96 minus the square root of 1,024, hit enter, divide by negative 32. And you should see 2 or 4. So what does this mean? So basically the rocket is going to shoot up and it's going to go past 128 feet. It's going to go higher than that. And then it's going to stop and it's going to turn around and come back down because gravity is pulling on it. And it will hit 128 again at 4 seconds. So here we didn't have a negative root. That rocket hit the 128 feet twice, going up and coming down. So as I promised, I need to give you a way to remember this formula. So this year we have danced. It is now time to sing. I'm going to give you my version of the quadratic formula song. It's a repetition where if we were in class, I would sing and you would sing back to me. This song gets stuck in your head. It is what is called an earworm. I have had students 4 years later, when they see me, start singing it. I've seen people tweet about it this year. So here it goes, everybody. Okay, so the X equals, so here's the song. The opposite of B, and then you would sing, the opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. All right, I'm going to do it again. Totally embarrassing myself. You guys know I love you if I'm doing this by myself. Okay, here we go. The opposite of B, the opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. There are some other versions. I will play those in a later video, But right now, that should help you remember the song. The most important thing today, number one, make sure all your terms are on one side and zero is on the other, and then do your substitution. Be careful with the b squared minus 4ac with your positive negative signs, and don't forget to press enter before you do the divided by the denominator. Otherwise, order of operations are going to mess up in the calculator. So guys, you are actually going to love the quadratic formula. Trust me, just give it some practice. We're going to practice again tomorrow. We're going to do a third day with a little bit more description about what that b squared minus 4ac is. But guys, the quadratic formula is the best way to solve a quadratic equation. Have a great day.